Hi everyone, this is the project closeout video for Paideia, project ID 11002227. We were funded in Fund 11 for Cardano Open developers. We entered this challenge to build an open source DAO infrastructure for Cardano. The original proposal was basically just smart contracts written in Aiken and a CLI or command line interface to support the off-chain side of using those smart contracts. The contracts are intended to allow permissionless DAO creation, governance token voting, and an automated treasury spending where a pass vote directly triggers on-chain transactions with no trusted intermediary. This can even include allowing a DAO to interact with smart contracts on-chain. The team was myself, Marty, handling the front end and off-chain code, and Luivatra, who built the Aiken smart contracts. We received 195,000 ADA to produce this project. We wanted to meet this goal because DAOs should be automated. I found that a lot of DAO behavior in crypto would involve maybe an on-chain vote tally, or even not on-chain, and then a manual fund transferred based on trust. And sometimes you'd find it would be a multi-sig wallet, but we wanted a fully featured on-chain DAO that is truly decentralized. We built the same kind of thing for Ergo and thought that Cardano would benefit as well. The off-chain code and front end we built allows any user to interact with these DAOs. Even if a website goes down or is no longer hosted, you could go to GitHub, download the code, and follow the instructions to run it yourself. So all the instructions are here in GitHub. How did we progress? It took a bit to work out all the details for the smart contracts. We started off with sort of the general requirements. I won't read all this document to you, but you can check the basic DAO spec on GitHub and sort of read through our thought process while developing the Aiken smart contracts. We also learned that even when you write good validator scripts on Aiken, a lot more work remains to get the off-chain code to interact with them. This led us to build a number of helper functions which do things like parse enterprise and staking wallet addresses, address parsing. So you can also use this code for your projects. So address to Plutus Data and parse Cardano address. And it differentiates between an enterprise address and a staking wallet. So that would be like a smart contract address versus one of your personal ones. We had to fully parse and decode the on-chain data to ensure when building transactions that satisfied the validators, we took into account the vote outcome, the exact amount the treasury should pay out, uh, and we had to make sure that the action tokens got burned so that the action can't be reused. So that would be here in parse action datum. Normally, Blaze automates those things because it's designed to build transactions for you. But in our case, because we had reference scripts and Aiken scripts that Blaze couldn't parse, we had to build a number of helpers to extract that. So we decoded it and pieced it all back together manually. You can check all that code. It might be useful to you for your projects. We ran into issues also where Cardano has a 16 kilobyte on-chain size limit for a transaction. So we couldn't just take the extracted Aiken scripts. We couldn't just build the scripts and then use them. We had to actually put them on chain as a reference script. Otherwise, we were just running into that 16 kilobyte limit. Um, I also built a front end for that, which deploys them and verifies their deployments. So that allows an end user, so even if somebody wants to launch their own DAO, knowing nothing about code, they can do that here. See, so that sends that transaction on chain, and then it's going to keep track. If you can see this here, this is the one I canceled, and now it's going to pull the blockchain using Maestro. It'll continue to pull to find when that's done, and then once that one's on chain, it'll do this and then this. So you can do sequential script deployment, and that allows you to get around the 16 kilobyte blockchain limit. There's a full front end for that using Next.js, so you can use that for your own projects. So the core milestones were completed, and we talked about that in another video. So that would be DAO creation, proposal voting, and treasury execution. They're all working on testnet. I demonstrated that full flow in this video, which I'll link in the notes, so I'm not going to repeat that here. The original proposal specified CLI tooling only, but we built the full front end, which you can see in use in this video. We also built a SIP68 token deployment module and the reference deployment script deployment module. They're completely standalone and can be used in your own projects. So check the code. It's all here. It's done in Next.js with TypeScript and strict typing, so you can use that for your own projects. What's next for Paideia? We have requested funding to take this to mainnet in like Fund 13, Fund 14, but we were unsuccessful. If anyone has appetite for us to continue the work, send us a message. We're happy to proceed further. We've left some to-dos that would really take this to the next level. Besides just getting it a security audit and getting this to mainnet, we also wanted to make it so that DAO could interact with smart contracts. Currently, you can basically just send funds, but we've designed the whole thing so that you could interact with smart contracts if you wanted in the future. It would just need a little bit of extra code. So we'd love to get that done. So let us know if you would like us to make a proposal in the next fund. We wanted to thank the Cardano community for funding this project. It was really interesting to work on and we learned a ton. Thank you for trusting us to produce it. We hope this code is useful to others. Please check GitHub. See if it's useful to you. Hopefully it's useful to somebody. Thanks again for listening and talk to you soon.